In this section, we're looking at limits involving infinity, asymptotes, and curves. So let's first look at what our indeterminate forms are. Those are numbers that don't actually have a value. So infinity over infinity, 0 over 0, infinity minus infinity, or 1 to the infinity power. So if we have anything that looks like that, we have to work a little bit harder. So we're going to put next to that work harder. However, if we get something that looks like 1 over 0 or any number over 0, then we consider that to be infinity or does not exist. So let's look at this first example. Here's our function y is equal to f of x. If we look at x approaching positive infinity, that means x is going in this direction. Our function is approaching the value of 1. And if we look at x approaching positive infinity, we can see that our function is approaching -1. So this is a graphical way of determining the limits. Next, we want to look at a couple examples. Let's look at the limit as x approaches infinity of 4 over x squared. Well, that would be, we can take out the 4, and we get the limit as x approaches infinity of 1 over x times 1 over x. So now if I break it down into its individual factors, this would give me 4. 1 over x goes to 0. 1 over x goes to 0. So this limit would be 0. Let's look at this limit. The limit as x approaches infinity of the sine of x over 2x. Now we know that the absolute value of the sine of x is less than or equal to 1. So what we're going to do is we're going to say that the limit as x approaches infinity. So we want to use this. So this is -1 is less than or equal to the sine of x less than or equal to 1. So this would be the sine of x divided by 2x. And that's less than or equal to the limit as x approaches infinity of 1 over 2x. And here I'm going to get the limit as x approaches infinity of -1 over 2x. So now let's use the sandwich theorem. The limit on the left is 0. The limit that we're trying to find is limit as x approaches infinity on the sine of x over 2x. And then the limit on the right is also 0. So therefore, by the sandwich theorem, if this limit, as we said, is 0, and this limit, as we said, is 0, then the thing inside also gets squashed by the sandwich theorem, and it becomes 0. So therefore, our answer is the limit as x approaches infinity of the sine of x over 2x is identically 0. Okay. Let's look at the limit as x approaches infinity of 4x minus 7 over 3x plus 2. Now, as you can see, the numerator goes to the infinity and the denominator goes to infinity. And this is one of our indeterminate forms that we were talking about at the beginning. So that means we need to work a little bit harder. So what we're going to do is we're going to divide the numerator and the denominator by the highest power of x. And for us, This is x to the first power. So therefore, we're going to get the limit as x approaches infinity. And so now I'm going to get 4x divided by x minus 7 divided by x all over 3x divided by x plus 2 divided by x. So that is the limit as x approaches infinity of 4 minus 7 over x all over 3 plus 2 over x. Now this term 7 over x, we know that limit is going to 0, and 2 over x is also going to 0. So therefore this limit is 4/3. Now let's look at the limit as x approaches positive infinity of 2x cubed minus 6x plus 1 over 5 minus 4x cubed. Again, the numerator is going to infinity, the denominator is going to infinity, and we get our indeterminate form. So we need to work harder. So again, we divide by the highest power of x, and we get the limit as x approaches infinity of 2x cubed over x cubed minus 6x over x cubed plus 1 over x cubed, that entire numerator divided by 5 over x cubed minus 4x cubed over x cubed. So that gives us the limit as x approaches infinity of 2 minus 6 over x squared plus 1 over x cubed, that entire numerator divided by 5 over x cubed minus 4. So we take that limit, and when we take that limit, we get that 6, I apologize, we get 2. This term goes to 0, this term goes to 0. So in the numerator, we just get 2. And in the denominator, this term goes to 0, so we just get -4. So our answer is -1/2. In this problem, we also get infinity over infinity, our indeterminate form. So we're going to, again, divide by the highest power of x. So we get the limit as x approaches infinity. Now we're going to get 8x cubed divided by x cubed minus 3 divided by x cubed over 2x cubed divided by x cubed plus x divided by x cubed. And that entire quantity is inside the square root. So now we get the limit as x approaches infinity. We're going to get 8 minus 3 over x cubed divided by 2 plus 1 over x squared. Again, that entire quantity inside the square root. So now as we take the limit in the numerator, this term will go to 0. In the denominator, this term will go to 0. So now we get the square root of 4 divided by the square root of 8 divided by 2, which is the square root of 4. The answer is just 2.